Good morning, everybody. Good morning, good morning. This is Julia Gerlach. I'm with No-Till Farmer, and I'd like to welcome you to today's No-Till Farmer webinar, which is a product demonstration of the residue breakdown and nutrient release aid excavator from Meristem Crop Performance. Sorry about that. And we are fortunate today to have Larry Fiene with us. Larry is the CEO of Planet Earth Agronomy based in Wisconsin. He's a renowned expert in the area of biologicals and the promise they hold for improving yields and soil health. Fiene has 30 plus years of experience in providing agronomic answers to grower challenges. Joining him today is field agronomist Jake Fiene, and they're tuning in to us from Black Earth, Wisconsin in the southwestern part of the state. For today's webinar, Larry and Jake are going to talk about the impact of excavator on cornfields, including the science behind speeding up residue breakdown in order to create an ideal seeding environment, improve seed-to-soil contact, and cycle field available nutrients for your crop. And they'll be sharing some demos to show the differences between treated and untreated plots, and they're going to share some university data from research trials. So before I turn things over to Larry, I just have a couple of quick housekeeping items that we want to make you aware of. On your screen, there is a control panel with a Q&A icon that will allow you to submit questions at any time during the presentation, and we're gonna get to those at the end of the presentation. If for any reason the webinar is disrupted or you're disconnected, just go back to the invitation email that you received and rejoin the webinar through that link. With that said, thanks again for joining us, and I'm gonna turn things over now to Larry and Jake Fiene. Thanks for joining us, you guys.
Thanks, Julie. Yeah, I'll probably be doing a fair amount of the talking today. Jake was down at the Deer District last night watching the Bucks game, so he may be a little hoarse this morning. We also have Elliot Nels with us from Ohio. Yeah, he's a big Ohio State Buckeye fan, but we're not going to hold that against him today either. So we appreciate the opportunity very much. It's a fun product for us, and kind of I'll talk a little bit just for a few minutes about our journey on kind of discovery and so forth. So yeah, I started out in the business in 1981. So this is actually my 40th year in the ag business, and 38 of those years were with what is Winfield United right now, a division of Land O'Lakes. And during that time, I had a lot of opportunity to look at different products for stock breakdown, and for residue breakdown in general, because we did work on wheat a little bit too, besides corn stalks. And we've tried a number of different products over those years. We did a lot of work at one point with fish, and we did a lot of work at one point with humic acids, quite a bit of UAN work to see what we could do to start to break down corn stalks so we could get a better stand in our no-till fields here in the upper Midwest, and we struggled a lot with that. 2 years ago, as we started looking harder here, we came across a study that was done by Auburn University, and they had been doing some work for the last few years on different microbial consortiums, and it was fascinating the improvement that they had in their studies over UAN, humic acid, and some of the other things that we had done some work with in the past. So intrigued, in 2019, we approached the company that had invented the materials, New Life Biosciences, and worked with them to do some research trials in 2019. We have a partnership with them now on the development and improvement of the stock residue breakdown product that Meristem markets as Excavator. So Excavator is the brand that we have in 18 states, and we're super happy with our partnership with Meristem. Great company to work with. They are all about performance, and it says it in their name, but they really want to see this product be effective and cost effective for growers. So we have a lot of strip till, a lot of vertical till, and a lot of no-till in our marketplace here in the upper Midwest, and growers have really struggled. Some of them have left no-till, some have left. Even the vertical till guys have left and gone to high-speed diffs because of trying to manage these huge amounts of stock and residue here that we have in our area. So we're going to walk you through some trials that we have here at our plot in Black Earth, and I'll just throw a plug in next week on Friday. the 30th of July is our big research field day. And if you have an interest, I think you can probably look for a link either on the Meristem website, or you can probably find it here at Lessiter Media Communications. If you have an interest, you can RSVP. And we have an NTPA tractor pull afterward after our test plot. You're welcome to stay for, but the plot itself starts at 2 o'clock. So I'll throw that little bug in your ear. If you really want to come and see this in person, you're more than welcome to come out to our trials. So let's talk a little bit about the science, and we'll walk you into some of our trials, and you can kind of see a little bit about what's going on. So really, the thing that happened that made this all possible is the science that was happening in 2 different bodies of work educationally in the U.S. And I'm going to hand this camera over to Jake now. He's going to just kind of give you a little bit of help us out here a little bit. So the 2 areas of research that were happening were in the area of hydrocarbon breakdown and remediation and using microbes. Some of you may remember that there was a big spill in the Gulf of Mexico, the BP Deep Horizon spill a few years ago, and it was going to be the worst ecological disaster in history. And then they flew out some microbes, sprayed them onto the oil slick, and it miraculously, those microbes ate up all the oil, and within 12 months they really struggled to find any oil residue. And so it was apparent that these guys really knew their stuff. And the group that we work with is outstanding in that area. They work with large oil field issues where they have a lot of contamination, and they have to break it down and get it back, remediate it back to original grass or sagebrush or whatever is indigenous in the area. So they have pioneered some really good microbes. They also use microbes and have worked on the delivery method, which has really helped us in agriculture a lot. We handle, this material is sporulated, meaning it's tough, hard spores. They're all microscopic, so they'll slide right through a 120 mesh sprayer screen, but they are in a tough resting form, so they're not alive. So you don't have to worry if you're spraying a herbicide with them. You can put them in with all kinds of different things, and it won't hurt these because they're not alive. They're in a resting state. Once they hit the soil or the residue, they'll go through the cracks and enter into the residue and start their feeding. But getting back to the science behind this, so these remediation guys had their body of work, and then at the same time, agricultural microbiologists were working on breaking down cellulose for cellulosic ethanol. And a lot of work had been done on trying to improve that. Of course, some of that's been abandoned now, but the research and the work that was done, it was invaluable in that they understood which species were really effective at breaking down corn stalks and wheat. So the 2 kind of merged together, and so some of this work was shared. These guys get together at these seminars, and they came up with these formulas and started testing them. Auburn did a bunch of work, and they're the ones that really attracted our attention when they did their work on this particular product on excavator material. That is a 6 microbe consortium. It has 6 different microbes in it. Some of the microbes that are in this consortium are just straight carbon eaters. So they break down anything with a carbon backbone. So they will chew and destroy carbon. Some of the microbes that are in this consortium provide a surfactant to the other microbes so that they're more mobile and they can get around more easily, so they can be more effective. So just to give you some idea on performance, Auburn's data showed that if you did nothing to your corn stalks at all, just left them after you harvested, and you came in and you measured them as a percent of the weight from the fall until the spring, about 6% by weight of your corn stalks disappeared. Okay. When they put on UAN, they had about 18% reduction by weight, okay, of the corn stalks in their study. When they used a humic acid, they were at about 20% reduction by weight. When they used the formula that's in excavator, they had a 50% reduction by weight. So a substantial increase in the amount of residue that was fed on. we were under the impression that a lot of our early results, which were successful from the 2019 applications, came just as a result of us spraying it and having better seed bed in the spring. So the coulters on our no-till planters could cut through the residue more effectively. We could get seed soil contact that was much better. We didn't pin trash. We just saw a much better stand, and we thought that was probably why we were getting these improvements in yield and improvement in stand quality in 2020 in the spring. Turns out we were wrong. We had another company that was looking at some of the same type of work, and they were capturing nutrients in their study, and they were picking up a significant amount of nutrient release from they were doing it on grass, stubble, and on wheat from the western states, and had very good results with regard to just nutrient release. So then we did our own study with corn stalks, and we found out that yes, indeed, a lot of nutrients came out of the corn stalks and were released into the soil profile. So it was almost like adding another application of fertilizer to our corn, and that was what was giving us that extra green up and growth and some of that staging. We were about a full growth stage ahead in the spring of 20 in our trials where we had untreated versus treated. And again, we thought it was initially probably because of just a better stand, but it was actually because we had really good nutrient release. So, you know, a lot of this, some of the challenges that we have with this is just looking at how can we quantify it? Because, you know, we can look at a lot of qualitative things. We look around in here, and Jake's going to show you some of the differences in the stand and so forth here in a minute. We're in our treated trial, and he's going to show you some of the residue down here. But we had to really come up with a way to kind of quantify the breakdown of stocks. We couldn't go out there. You know, Auburn was lucky; they had about 20 interns and kids that could go out and scrape up all of the corn residue and put it in a bag and weigh it. We don't have that opportunity on the farm, so we needed a faster in-field type method. So we developed a corn cutting tool that mounts onto a penetrometer that we use, you know, as agronomists. A lot of you guys that have seen agronomists or work with them, or some of you are maybe agronomists, have used a penetrometer to map out compaction in a field. We use that same compaction tester tool, and we put our own mount on it, which is basically a Yetter coulter, straight Yetter coulter on it. And then we push down through the stalks and we take the PSI readings off of it. So that gives us a nice indication of how hard and flexible the stalks are, because we're looking to measure the dynamic bending strength and the cutting ability of a Yetter coulter in here. Not that we're tied to Yetter or anything. I'm not paid by them or advertising for them. We're going to probably talk to the precision planting guys and everybody else about it, because we'd like people to have the technology and utilize it to get better ideas on when a field is ready to plant, and also how the products are working that they're evaluating from a stock degradation standpoint. So we'll show you that here in a minute, but I think first we'll just kind of show you the plants, and I'll walk around and show you kind of how these corn stalks look as we get in here. So we're in the treated area, and as we look here at the corn, you can see that we're about shoulder high for ear placement. We look for that because we really want the healthier our corn is, in general, in our part of the world, the higher the ear placement is. So when we have really healthy, really vigorous corn, we get nice high ear placement. And in here, we also have corn that I guess, you know, I can't reach the top of it. I'm 6'2", and I can't get to the top. I'm going to say that the corn is 9 feet tall. I'm just going to guess. Some of it could be 10 feet tall in our treated area. And as we look down at the corn stalks, Jake will give you a little look at how these corn stalks look. These stalks are pretty mature. There's really not a lot left. Even the ones here that are still have a little bit of pip in them, they're pretty well beat up. And the other thing we see is this is where the planter ran through here. And as it ran through here, it was able to start by cutting through. Now remember, this just went on in the fall. It wasn't like a year or two ago. And you can see in here, some of these are, the stalks are actually sized by the planter. When the planter came through here, it cut the stalks. When we go over into the untreated area, you're just not going to see any stalks that are cut. We basically will see a lot of cut marks, but not where trash was actually cut. When we look down here and we look at the stalks themselves, we can see we've got brace roots on here. We've got good sized plants in general as we come through. It's still not perfect. We've got a straggler or two in here, but in general, a decent stand of corn in here. And then as we stand up here and walk out, we've got posts to kind of look at also with regard to the height of the corn. So you can kind of see our white post as we walk out here, and we'll walk out of the plot. And I think you can, as we walk out, we'll walk a little bit away from here, and you can kind of see our no-till trials. So this corn here, in this area behind me right now, this corn is treated with excavator. Okay, and we're going to walk down, and I'm going to show you some. We left some openings so that we could get a close look at how the stalks are breaking down in here, and we'll walk over here and look at how these stalks are basically like blown up almost. There's the pith is eaten, and the way this material works is the microbes land on top of the microbes will land on top of the corn stalks, and they will rinse down with moisture, dew and rain and so forth. We'll get them inside. If there's cracks in the outside of these stalks, they'll go in and penetrate in, because again, these are very small little microbes. They can get right into that pith, and that's really what they want. They want to eat the pith out of these corn plants and out of these corn stalks. And so they move down. The good news is when we get down in here to the base, they've already fed a lot at the base. So when we grab these corn stalks in the treated area, they pull right out. They don't, there's no roots, to speak of. They're all rotted down, and they're all broken down. They're all very, very much brittle, easy to break. Really, a lot of them are flat in here. They've lost all of their pith, so they're very much beaten up. These are the stalks you can kind of see here. There's almost nothing left of these corn stalks. The other part that I like about it, since you can pretty much just cut right down through the root ball, there's almost nothing left in terms of the root balls on these. They're really shot. And we're in July. We should have some pretty good breakdown, but not this year. We went about 11 weeks with almost no rainfall at all. First time that's happened in many, many years in Wisconsin. So we had a super dry April, May, and June. Very, very dry weather. Now we're going to walk over to the untreated area. I'm going to show you this. So these are what the corn stalks look like in our untreated trial. As you get here, these are untreated. So these stalks, you can see these are much bigger, heavier. They are starting to break down now, but these stalks are going to be much more intact. They're going to have more. We can still break them in half, of course, but they don't want to come apart. There's still some flexibility here. There's still some pith inside these. It's nice and white and flexible, and that's gonna hurt us, because when our equipment comes across here, it's going to have a tendency to bend and hold together and pin trash down in the zone. Okay, so it's not what we're looking for. It didn't blow these up. These aren't all rotted down and blown up like the other ones are in our treated area. Now we're gonna show you kind of how this tool works. So here's our tool. All right, it's really not very sophisticated, fellas. Any of you can make this in your shop, and we're okay with that. All right, we don't plan to step in the way of this at all. If people want to make these and put them onto their compaction testers, that's great. That's just fine with us. We just want people to be able to kind of quantify how these products are working. So we're going to take a few stalks. We're going to push down on them, and we're going to get a reading here. I'm pushing down now. I'm at 300. I'm going to the do not exceed area and I'm not getting much. I'm going to go into another little spot here. Oh, I got through that one at about 300. Here's some that I'm going to push into 250, 350. Okay, so we're getting through them, but they're, as you can see, they lay on top of each other, and these are pretty tough. These stalks are, you're not going to break these up real easy. Not going to cut through them real easy with your coulter. Okay, we're going to walk back now, and we'll walk back in our treated area, and we'll just cut through some back here, and we'll take a look and see what the difference is. We can go in here. I guess this is fine. So we're back in a treated area. All right, so we're going to cut down through. That stalk was about 75 psi. Here's some fresh ones. That's not quite 100. We're going to a big wad of them here. Push down. We could probably be up around 200 on some of these, but way different. Like these just slice up nice. You can see the differences here as we're cutting them. They just cut up beautiful. You can chop down through any big pile of them. It just cuts in nice. And then one of the big things, like we were talking about here earlier, is let's take a look at a root ball. Oh, there aren't any. Here's a root ball. We're trying to cut down through a root ball. There isn't anything left. These root balls are gone. Basically, they're all eaten up. Even the crown roots are gone. Let's find one that's still halfway together. You know, like I say, here's a stalk. This is a good example. This stalk's shot. It's brittle, comes right apart. Here's the root ball that was on that stalk. I'm going to try to salvage it so you can just see a little bit about how much decay there is. But you really have a hard time finding the root balls. This is what's left of a root ball on the treated area. Almost nothing there. If you're a potato grower, this is great news for you, because when you go to dig potatoes, if your root balls are gone from your corn crop from 2 years earlier, you're a happy camper. If you're a no-tiller and you don't have root balls to contend with, I think you're going to be really happy to have that opportunity, not to have that problem with your planter. To be able to just chop right through, cut these stalks, no problem at all with your coulter. You're just gonna cut right up as it rolls across, and you'll get better seed to soil contact. Now we're gonna walk down in the untreated, and we're gonna walk in, and I'm gonna show you some other. Okay, Jake's gonna show you the residue first here. He's gonna show you kind of what you can see from the residue standpoint. We're in an area that's, you know, you can see the layers of residue. We've got quite a bit of residue underneath, down in under the where it's been moist. I'd say we have decent situation as far as stock degradation goes. Not bad, but you know, we still have these stalks that have been busted loose, that laid around, and there's still some flexibility. Even the middle of July here, you know, after they've had the summer on them, pretty nice inside. They're not all brown and broken down, and they're still harboring also some diseases. So let's take a look at the leaves here, and we'll show you some differences that we noticed when we're in the untreated and the treated. So here we're in the untreated area. This is eye spot. It's a lot of it, okay? We have a lot of eye spot showing up in here in our untreated area. These are fresh leaves. This leaf is up about 6 leaves up on the plant. And some of this is because the inoculum that we have is on the residue, and the residue has not been decayed And the microbes that we put on there have not been doing their thing, fighting off these pathogens. This is gray leaf spot. We're getting our first little taste of gray leaf spot here in Wisconsin. Just in the last few days, we've noticed it but it's in the untreated. The treated area so far, it still has strong plant health and still looks pretty good. We've got a little bit of Goss's wilt in the plot also. We got a little urea burn here too, but we've got some Goss's wilt. I noticed the other day when I was walking through this, that we had some in the field here. And then I think I'm going to have Jake just show you a little bit about how these areas in the untreated plot look as far as uniformity or lack of uniformity. Yeah, you can see all the residue down here. So here we are. This is our residue layer. Okay, and we've got corn stalks in here, still pretty decent. You know, still have some. Again, we've got corn stalks with some pith. It's not black, it's still flexible. Still could potentially cause us some challenges in terms of planting. And then if you look at our corn stalks here, we actually we don't have a real bad, this was a good planter. We don't have a real bad situation, but you can see here, here's a nice size stalk that came out of the ground on time, did pretty well. This is a little behind. This one here is a lot behind. This plant here is basically gonna suck moisture and nutrients, and it's not gonna set an ear. It's just gonna be a weed competing with the rest of these plants. We got a little gap in here. We got another gap in here. We've got a gap in here. We've got some gaps where the trash pinned in struggled to get going. Again, we just have to grab the bottom leaves off on here. This is anthracnose. We've got some anthracnose in this area of the plot, along with some of our eye spot. There's some anthracnose showing up in here. A little touch, there's some gray leaf right there, a little bit of gray leaf spot. So we see more disease in here because the inoculum is alive and well on our residue down here. So we think there's probably an opportunity from a plant health standpoint to just look at some of these residue breakdown products as an opportunity to eliminate some of that inoculum and cut back a lot on some of that. This is what we see sometimes. Goss's wilt, again, none of this in the treated area. We got some Goss's wilt over here in our untreated area. In the
ear placement too, Larry.
Yeah, ear placement. Jake, thanks for reminding me. Yeah, so here's our ear placement. First of all, we're not uniform in flowering here right now. So we've got two plants here that have ear placement that's no ear on this one, no ear on this. No ear, well, no silk yet. I'm not going to say ear. No silk. Here's some silk. Okay. No silk. And then we jump across. We've got some silk. So we have very uneven. What comes out of the ground uneven also has a tendency to tassel and flower. Here's a plant that looks like it's fairly healthy. There's 2 out of about 5 here that have silk on them. We're gonna walk back. We're gonna walk back over here into where we can walk out so you can see the height of the corn. Get a look at that. First, the treated area. Here we are. This is it. So that's our stake down there. Yeah. That area. And it's still, I can reach the top of the tassels without too much trouble in here in our treated area. Pretty easy to touch the top of the stalks, the top of the tassels. So we're probably a good foot and a half shorter. I would say in our untreated area, we haven't done all the standard deviation tests yet, but we plan to do that. And what our hope is that this summer, as we have our interns and our agronomists out in the field measuring the dynamic bending strength with this tool, as we start to cut these, and we're going to have several of these tools out, we start to collect data, we'll be able to look at, okay, if we're at 100 psi cutting with this Yetter Coulter, what does that translate back to in terms of our stand count, our final count, but also the standard deviation, meaning are we uniform between plants and are we at a high percentage of optimum yield? Because when our standard deviation changes, we see a significant reduction in our opportunity to grow our high percentage, 80, 90, 100% of optimum yield. So we're thinking we're going to see some correlation between stiffer stalks, higher PSI numbers will equate back to lower potential yield based on our standard deviation numbers. That's what our gut feeling is right now. So we've talked for a half an hour straight, and I appreciate everybody's attention, but I think maybe Julia or John, you may have a question or two, and we're happy to answer those if we can today.
Yep, we do have a couple of questions. So we have a few that came in before the webinar began, and we also have gotten a couple from our audience as you've been talking. So we'll start with those. Scott Jensen asks, are there any unintended consequences to soil biology in the soil food web or cover crop effectiveness?
There always are, unfortunately. Yes, the answer to that is unintentional consequences are something that you have to manage, I guess. So here's one that I think we should think about. Okay, in the soil, these microbes are aggressive, and we're basically trying to change the profile a little bit so that the microbes that are here do what we want to have happen, meaning they break down the stalks and they release nutrients. And we think now with this consortium, we have a great way to do that. An unintentional consequence is these things also crowd out other microbes and other types of things in the soil. One of the things that these microbes can do is they feed on chitin, which is eggs, okay? Some of the eggs that they feed on are nematode eggs. Now, that could be a big benefit if you're in a sand soil and you have a lot of needle nematodes like we do in some of our irrigated acres here. But it could be a detriment because some of the nematodes that are in the soil are beneficials. They travel around in the soil and they attack rootworm larvae. They attack grub larvae. They're part of the whole ecosystem in terms of reducing insect pressure. So that's something that we haven't studied yet. We don't know about. It's up in the air, and I don't want to dwell on it because we're super excited about breaking down corn stalks today. But we are watching that as a potential negative in that we could end up reducing beneficial nematode populations in soils long term, and that's something that scientists have looked at and are looking at, and we'll have some better data kind of going forward. Other than that, really, it's hard to come up with anything that would be, a super issue or a super challenge, with changing, with us basically managing the microbe population and the microbe species in the soil, because we think we have an idea of what our outcome is and what can help us grow higher yields, which would intentionally improve the uptake of nutrients by corn, which should benefit the soil. It should benefit capturing of carbon. It should benefit a lot of the other things. So these microbes, what they do in the soil is they basically sequester carbon in their bodies. They break down and make plant available carbon in the soil for the plants for energy. And they reduce the amount of oxidizing carbon, which goes off into the atmosphere. So they're very beneficial from that standpoint. So increasing the amount of that happening is a definite positive for not just agriculture, but for environments and probably for guys that are thinking about selling carbon credits down the road too, because I think we'll be able to show some strong data for carbon sequestering. Yeah, so we will probably come across some unintentional challenges, but as of today, it looks all positive for us.
Okay, yeah. And just sort of a follow-up to that, wow, I had a question and it completely left my brain just that very second because somebody else asked a question that I thought was more
Really
interesting.
no excuse for that, Julia. You know, you're,
It's called old
you're
age.
smarter than Elliot and I are, so you should have that dialed in.
So,
You-
anyways, well,
Were you at the Deer District last night? Aren't you guys based down by Milwaukee somewhere? Isn't that where you're
you would think
located?
I was, right? Well, if I remember it, I'll come back to it. But we've got a couple more questions also. Dave Luck is asking, uh, does a fall post-harvest or spring pre-plant application work better?
Yeah. So if you're planting corn on corn, I think you know for a corn on corn application, we would prefer a fall application just because we want to give as much opportunity as we possibly can for the product to get into the corn stalk, work its way into the pith, dissolve that pith out so that we reduce that flexibility in the spring and improve the planter activity and the planter movement. And I think that would be, a fall application for corn on corn. One of the worries that we had with this product after we saw the nutrient release data was all that nutrient being released potentially in the fall could be a challenge as far as movement. And the good news for us was when we did the full analysis and we looked at the nitrogen component, which is what we were mainly worried about in terms of leaching or loss, was that the nitrogen component that's released from these stalks is in the ammonium form, which is a big deal. It's 90% ammonium nitrogen, which is common because the microbes, they hold that nitrogen inside their bodies basically. So you end up with an ammonium form of nitrogen, which is nice and stable. It attaches to the negatively charged soil particles, so it stays real nice and stable. So as they break that down and they produce some N in the soil, they do a nice job of of stabilizing it so it doesn't leach and it doesn't gas off on us. So that was good news. The So we would lean though. Our worry, I can say, was how much nitrogen, how much nutrients are released. Soybeans in our area have a tendency to get really leggy. They get lanky if they have too much nutrition sometimes. And so our thought was this year, and we have this in the research trial, we have put on some spring applied product for our no-till beans, and we don't like it. We like the fall applied stuff better. The stalks, the same issues. The stalks were more brittle. The the planters ran right through it nice. We got much better seed soil contact, so our bean stands look better where we put the fall application on. So we're leaning toward fall. We understand though that fall can be a challenging time to get out and spray. You know, last 2 years for our plot sprayer, we had to park it inside because we ran up against frost and freezing conditions. We had to run a little bit of fertilizer with it so we could keep the lines, clear because we put a little fertilizer in as antifreeze in there. So we used a little UAN with it. That helped us, but you're up against, winter. And so that's the challenge with that application. Plus, we found a lot of growers, ourselves included, like to clean up their sprayer, winterize and put it away. So, it is a detrimental thing from a standpoint of having to drag the sprayer back out if you're going to make that application in the fall. But if you're a true no-tiller, this is definitely something to take a look at. If you're a vertical till person that does a fall vertical till and a spring till, this is definitely something to take a look at. Jay can kind of tell you a little bit too.
Yeah, and what we found too is the guys that have continually applied, they're on their second year of, applying excavator. Seems like the breakdown has been faster as well, because we do think that microbe population is building over time within the soil. So we've seen that too. But yeah, like Larry said, I think fall applied is definitely the way to go if you are able to make that happen. And he talked about earlier how these microbes are in a sporulated form. So from an operational side, it does make things a little bit easier if you are going out there to do a burn down. You're able to put excavator right in the mix you're not gonna kill them like other biological products in the market. So
Yeah.
Okay, great. And I think that what you guys were just talking about sort of addresses Kurt's question. Kurt is asking how long of a benefit is realized. He's asking about the application interval. Basically, do you have to apply it every year, or what are you seeing?
Yeah. So Jake did kind of touch on that a little bit. We think we're getting an increase in population of some of the microbes, specific ones, Compostia, and some of the other ones that are really good at breaking down carbon. We think we're getting a little bit of an improvement there in those populations, but in reality, this is a bell-shaped curve. Okay, so one of the things we didn't talk about yet is, and we need to, is quantifying the amount of microbes that you're putting on. So if you are buying a product to break down residue, be sure to read the label and see what the CFU count is, because that's the colony forming units. That's actually what you're buying, is the quantity that you're buying is the number of CFUs. Okay. So we feel that we need a lot. So we put 650 billion CFUs on when we make the application. And that's a high number, because after these things wake up, about every hour, they're going to double in population. Okay. But a lot like other ecosystems, these microbes are also food for other microbes. They're a food for other microbes that are in the soil. So they only get a chance to get this increase for a short time. And then the other microbes that eat them also come up. Okay. And so they start to feed on them and knock their numbers down, and then it tips off the backside and goes down. That period of time varies a little bit with organic matter. It varies a little bit with temperature, your weather conditions during the application period, that type of thing. But generally, 30 to 60 days is about when you're going to see the peak improvement. Now, the microbes, we think, that get inside the corn stalks stay active for a long time. They're in the dark, they're in moisture, they're in with carbon source, carbon backbone molecules that they love to eat. So we think they stay way more active inside, but outside, we think that there's the bell-shaped curve that takes place, and they fall off pretty fast. Especially, I'd say at 60 days, we probably would have a hard time discerning that we made an application after that period of time.
Okay. Oh, wow. So do you think you would ever do it multiple times? I mean, you have talked about doing fall and then spring. Would you ever do it even more than that?
So we're actually changing the formula going into 2022. We like what we see here, and we love the formula that we had. Great little product, and the carrier that we had was very effective. It kept the product moist a little bit longer. It provided a starter for the microbes to kind of get going. But the problem was we had an independent research company do an evaluation. Our partner in this New Life Biosciences, and it was evaluated here in Wisconsin at Whitewater by Agritech Research. And we went down and visited those trials the last 2 months. And they did a fall application, just straight with the material. They did a spring and a fall application. And then they did a fall application, and they added a specific surfactant that we asked them to put in. That was the best application that they made. The surfactant allowed more of the microbes to enter the stalks that had cracks in them. And that provided faster breakdown, and it looks like more complete breakdown. So it gave a better opportunity. Plus, it looks like it also helped move the nutrients out of the stalks more effectively, because we had much better color in the corn where we had the fall application with the surfactant than we did with some of our other trials down there. It was a randomized complete block study, and we're looking for the yield data at the end of the year, but we're very, optimistic that is going to show some real strong results. The trials with the surfactant really looked good during the summer here. So.
Okay. And so the fact that they're getting into the stalks is maybe that's what's helping protect them from the super dry weather we've had. I mean, in Wisconsin, it's been dry. It's
Yeah.
been even drier elsewhere. But so you haven't seen a real negative from that, from the dry weather.
No, we've been fortunate. We really haven't seen a big problem with, like I say, the stock reduction that we're seeing is good. Yeah, we had 11 weeks in some areas of Wisconsin without a drop of rain. Our corn was rolled up, our beans were wilting. We had some challenges here, some pretty significant challenges. And as you saw us walk around in these plots, this is not big corn for Wisconsin. This corn crop that's here in Wisconsin this year is a foot or two shorter than what we normally see for corn height. So we suffered early in the development on our corn crop. We're also cutting up corn, and we're not finding the 20 and 22 round ears that we did the last few years when we had adequate moisture. The corn was setting smaller ears, so we have fewer rounds on some of our hybrids this year as a result of just that super dry weather that took place. So, and again, these corn stalks, late in the season, they can provide some moisture, protection and hold some moisture in the soil. But during the early part of the season, they can also absorb some of that, and they compete with it for nutrients. Some of these residue levels that we have here. So yeah, we see some positive. We saw bigger differences this year with where we put the application on than where we did. So we were really excited about being able to take some of these trials to yield because we think we could have some really significant improvement in corn yields.
Mm-hmm. Okay. Scott Jensen asks a question. Have you trialed excavator applications with a calmer shredding stalk rolls or in a post-harvest flail shredded stalks? And what is the application rate of excavator?
So we have put out a lot of plots, a lot of trials. Okay. I think Jake sprayed 40 or 50 trials last year, side by sides. And some of those trials were where the growers were using shredders. Some of the trials that we had out, they were using vertical till tools and going in right after the application and hitting it with a real disc or an insight tool to knock just try to size the trash a little bit and get some soil contact so you can get some moisture into those stalks. And it's the effect that it has is similar across all tillage systems. Okay, these microbes, they really don't care. If you can put them in a situation for more success, meaning if you can get them into the dirt a little bit, get some darkness, get some moisture to them, you're gonna help improve your success opportunity. But here in the test plot in Black Earth, we just left the stalks untouched. We didn't touch them. We left them complete no-till. And in here, we have a significant difference in terms of cutting, and in terms of degradation. And probably, if we went out and weighed them, I'm sure we'd be substantial differences in the weight of the stalks. So we've had good results here in probably one of the more adverse years that we could use the product, being a drought, spring. So we had a poor year in 19. If you guys remember, the fall of 2019 here in Wisconsin and Minnesota, it froze in October hard. Ground froze up. We had a tough time getting any of our stuff out. So we had to park, like I say, sprayer inside, put antifreeze in it to get the plots out, and we had some growers that did that also. They parked in their sheds and kept the machines warm overnight. Then they'd wait for it to warm up, and then they'd go out and spray their product on. Those trials worked out much better than we thought they were going to. We anticipated a bust on it. We thought as cold as it was, there wouldn't be any activity. Turned out that around Christmas time, it warmed up. All the snow went away. It melted. Those microbes reactivated and started to chew on the stalks. It got cold again in January, but in the middle of January of 2020, we had a thaw. Got up to 50 degrees. We had rain. The snow went away again. The microbes reactivated and started feeding on it. We had another February thaw. warmed up in March, and by the time we got into April, it had worked really well. So what we thought in 2019 would not be a good performance year for us turned out to be much better than what we anticipated. The same is true this year. We really didn't expect it to work very well, but as we get around now and look at it and evaluate it, we're finding pretty good results.
Okay, great. We have a couple of people who are asking, what is the difference between trash breaker and excavator?
There's no difference.
There's no difference. Yeah.
Trash breaker is marketed locally in Wisconsin, Northern Illinois, Southeast Minnesota, and Iowa. And the Meristem guys, kind of like our search for the perfect product, we were able to find and work with New Life Biosciences that had the work that was done with Auburn University. Meristem approached us and said, hey, we would really like to have a product in the marketplace. Is there any chance that we can brand trash breaker? And so we gave them licensing agreement to make excavator. So excavator is trash breaker.
Yep.
Okay, got it.
Saying the use rate, it's a gallon per acre. I don't think we answered that part of that last question, so I just want to make sure that he was aware of that.
We've got a question. It says, it would appear that the carbon sequestration properties you've mentioned with excavator, I'm guessing excavator is a fungal dominated product. Is that the case?
No,
No.
it's actually a bacteria dominated product. There are fungi in it, but the primary activity comes from bacteria, from bacterial microbes.
Okay. All right. And then we have a few more questions that came in. Let's see. I'm not sure I understand this one completely, but it says, do you have qualities for wildlife deer plots? So I'm not sure if that makes sense to you, if you know what they're getting at.
We haven't done any wildlife deer plots. In fact, the deer hang out here and they eat a lot of our test plots. So we have a tendency to chase the deer off from this area just so they don't mess up our data. But we of course work with a lot of people. You know, we're in Wisconsin. Anytime you're in Wisconsin, Minnesota, Michigan, you know, you have the largest deer hunting population in the country. And so we do have a lot of people that put deer plots out. If you have a residue issue on your deer plot, and a lot of people will take out mulch or they'll take products out, natural products out to start to develop some till in their plot to get some good organic matter, especially if you're in some of the challenging glacial soils that we have here in Wisconsin. The addition of microbes is a good thing to just keep the compost breaking down. And so this product could be used as a way to improve composting of your residue. If you're hauling leaves out to your plot, or if you're hauling chopped, shredded bales or something like that out to add some organic matter to your food plots, so that you can get your brassicas and your other species to grow, way to help you break that residue down and improve your deer plot.
Okay. All right. We have a question that regards cover crop. It says, I roll cereal rye and vetch and clover and plant green. I'm interested in how to get the rather tough stems of rolled rye stalks to decompose fast. The softer, leafier material seems to decompose well enough, but we don't want the cover crop to decompose too fast. Otherwise, it lets in light for the weeds to grow.
Right. Yeah. That's a challenge for us because, you know, we did a lot of work early with cover crops. We love cover crops because we've seen some tremendous results in our corn on cornfields where we've gone to some cover crops. We have to be careful because here, specifically with regard to rye, when we're rotating into corn, the University of Wisconsin did a pretty extensive disease levels just from green bridging over some of the pathogens from rye. As the rye was dying, its immune system was dropping off, and these particular species of pathogens were feeding pretty aggressively on those roots and building in population. And then we were planting corn into some of that. And we had a transfer of those pathogens over onto the new corn roots on those small corn plants as they germinated and started to come up. So we've been careful, a little careful with that particular cover crop in that type of a rotation. Beans, it doesn't seem to be as big of a challenge. So we've asked guys to kind of move that direction if they're doing a rye cover crop. We have a lot of rye used in the potato country here in Wisconsin, tremendous amount of that. These materials that break down corn stalks, this excavator product will break down rye very effectively. I mentioned earlier that some work was done by a large company in the West Coast area. That's one of the problems that they have out there is very low rainfall, and they have a lot of wheat, especially white wheat in the Blues area of Washington where it's pretty arid and it just doesn't break down. And so they were applying this and looking at nutrient with minimal moisture. I think in Wisconsin, a lot of our activity is actually coming from dew. You know, we didn't have much rain here for 11 weeks, but we'd have 50-degree temperatures at night and warm days, and we were getting probably 6 to 8 hours of dew forming on the trash and that was, I think, leaking in and giving us a little bit of extra activity, which helped, I think, with the breakdown. So, getting back to it, I think the rye will break down anything that has a carbon backbone like that, rye, corn stubble, wheat, anything that's straw and has a high carbon nitrogen ratio will probably be pretty good food source for these microbes.
Okay, great. And then we have a question about the nutrient release, and I think you kind of addressed this earlier, but I'll ask the question and you can say whether or not you did. So it's asking what's the fate of rapidly released nutrients going into winter when it's known to be the season of most leaching and high erosion. So I think that's that ammonium thing, but go ahead and answer that.
Yeah, so that was a concern of ours as a potential detrimental effect from from breakdown in the fall. That's why we did the nutrient release studies, and we have the data that we can provide too. Again, it'll be on the Meristem website. If you do want to pull that off there, that study will be in there. But the amount of ammonium nitrogen versus nitrate nitrogen was it wasn't like significantly higher. It was actually by far the majority of the nitrogen. 90% of the nitrogen was in the ammonium form and about 10% was in the nitrate form. In fact, when you looked at the untreated versus the treated, I think the leaching study that we had 30 parts per million of nitrate in both the untreated and the treated, okay? And about 300 parts per million of nitrogen as ammonium, 200, maybe 250 parts per million of nitrogen as ammonium nitrogen that came out of that study. And again, like the same amount of nitrate. So we didn't see any increase in nitrate nitrogen by going to the microbes in that study. And that was done with PNS labs out of Walla Walla, Washington. And it's pretty interesting. Most of your microbiologists will tell you that if you talk to them about this, that the nitrogen is in the ammonium form when you have a breakdown of carbon like this. That's how they sequester it. That's how it's maintained, is in the body of the microbes as ammonium. The other nutrients, the phosphorus that's released from the corn stalks, of course, is pretty stable. It's too stable in a lot of our markets because it ties up pretty rapidly on the soil. That's a little bit of a challenge. There's an increase in potassium, but not as much as there is in nitrogen and phosphorus. The potassium has a tendency to leach out of corn stalks all by itself pretty effectively. So it's not as big in terms of the amount that comes out of corn stalks compared to nitrogen and phosphorus.
Okay. Well, and let's do one more question. We are pretty much at the top of the hour. We'll do one more question and then we'll wrap it up. But the last one is about the shelf life. What is the shelf life of excavator, and is there an optimal storage and transport temperature?
Yeah, so we we have a specific way of formulating it in the liquid form. We keep the pH at a level that keeps the product stable. Okay, so as long as the product is in the container, it has a 2-year shelf life. Okay, if once it's mixed in a sprayer, you want to get it sprayed because it could activate over a period of say 3 or 4 days in the sprayer. So you really want to mix up what you need and get out and spray it and get it applied, and then you know again it'll work. But if you have the container, the liquid tote container, it's a 2-year shelf life.
Okay, great. And one final question: do you have it? Is it available in Canada?
Yes, we have been shipping to Canada. It's been a little bit of a challenge for us.
Yeah.
We did ship some biostimulants 2 weeks ago into Canada, and they let them go through, which was nice. So we we do have there is a fair amount of paperwork. You Canadians are pretty careful about letting these Americans send stuff up to you right now, but we've had luck. We have had some luck in exporting some of our products to Canada, so we would be able to do it. The challenge would be cost and logistics. That's really our biggest challenge. It's pretty expensive right now to send anything up there, and Perlator is really the best company to use for Canadian freight. And we just don't have a lot of Perlator locations here in the Midwest, so we have to hunt them out. So that all costs a little extra too, but we're more than happy to look at that if somebody is interested.
Okay. Well, I think that, somebody was commenting they'd be interested in being a dealer for you. So I'll just put it out there. They can contact you about that. All right. Well, I think we are about out of time here. And I just want to thank Larry and Jake. Thank you both for being with us today. Appreciate it so much. You have any final words for everybody?
Thanks for taking the time. We really appreciate it. So
very much.
We're
excited. Again, if you have an interest in seeing it for yourself, come on out on the 30th of July to Black Earth, Wisconsin, and feel free to look up any of this information on the Meristem website at meristem.com.
Yep.
Okay. Awesome. Great. Well, thanks again, you guys. And for everybody who's still with us, before we conclude, just a heads up that we'll send you a questionnaire to complete about the webinar. Really appreciate it if you could fill it out to help us with planning for future webinars. We will make this available on our website later on in the event that you want to go back and watch it again. And once again, I just want to thank Larry and Jake Fiene for leading this discussion about crop residue breakdown with EXCAVATOR. And I want to thank Meristem Crop Performance for supporting the webinar. And I also want to thank our producer today, John Bennett, for helping us out. And of course, thank all of you for joining us. And goodbye for now, I guess, and have a great day. Thanks so much, you guys.
Thank you, John.